Welcome back. It's time for video 5, the last video for Unit 2. With no further ado, let's get to share. Share. PowerPoint. Yeah, we're cooking now. All right, from the current slide. All right, this PowerPoint's going to take us into section 2.3. So we're going to take a look at things like intersections and unions and some set operations. We'll also get to spend some time with Venn diagrams. So for many of you, this will be new content. All right, so there's an overview look. We're going to look at intersections, unions, set difference, Cartesian products, and Venn diagrams. There's a lot of going on here. Not hard, but might be new. Okay, intersection. The key word is and. For something to be in an intersection of two sets, it must be found in set A and in set B. So intersection's pretty regimented. It says, hey, look, if you're getting into the intersection set, you better be in both set A and in set B, right? Intersection symbol kind of looks like an upside down U. Again, if we kind of saw this before, you can envision putting a little horizontal bar in the middle of that thing. It makes it almost look like an A, which is the first letter, and you guessed it, and. So it can kind of go that way. So intersection has to be in both sets. It has to be in set A and in set B, and then we would list it in the intersection. When we list an intersection, the order in which we list the elements doesn't matter. Okay. Contrast with union, which looks like a big old U. All right, union, the operative word is or. So for something to be listed as a union of two sets or a member of the union of two sets, A and B, it has to just be in one set or the other. If the element happens to be listed in both sets, we don't list it twice. We just list it once. It's in one or the other, even if it's in both. Okay? So again, the key word here is or. Union has one set or the other. Some examples for us. I created a couple of sets, called them A and B. Clever, I thought. All right, problem number 1 says let's do what's in A, and that's an intersection symbol. So we're listing the elements that are found in set A and in set B. All right, so we'll run our eyeballs across. It looks like 8's in both of them, and it kind of looks like 10 is, So they seem to be the only elements that are in set A and in set B. You guessed it. We got that one right. Good deal by us. All right, second one says let's do a union. Union tends to be more forgiving, all right? Intersections are more restrictive. For an intersection, you've got to be found in both. For union, which is what we're asked about in number 2, you've got to be in set A or in set B. So if you're in one of those two sets, you're in the union. Again, order in which you list these doesn't matter. I chose to go in numerical order. Some students will list all of the elements in A and then just augment by adding the elements of B that maybe weren't already listed. Okay, but the order doesn't matter. And in the answer for number 2, we would have had to compose a set that had anything that was found either in set A, namely the 4, 6, 8, 10, and 12, or in set B. So that's how the 7 got in, and that's how the 9 got in. All right, notice the 8 and 10 were already there. They were listed as elements of set A. All right, I went away from numbers and I went with barnyard animals, apparently. Set A's got those guys, and set B's got, looks like some fowl. All right, some ducks and chickens and turkeys and gooses. All right, so what do you got? Well, that looks like intersection. So for us to get in an intersection, we have to be in one set and the other. Looks like it's just chickens and ducks. All those other guys aren't found in both sets. All right, what about one or the other? This is going to be a pretty extensive set. All right, so it's going to have all the guys from set A and the other guys added in from set B. So I shrunk the font size a little bit better. You'll see that I tended to list all of the set A guys, and then I augmented that by bringing along the guys who were from set B, who had not previously been listed. And in that case, it looks like that might have been duck and turkey and goose. Okay. Empty set just makes things more entertaining. If you're intersecting with the empty set, remember the empty set's got nothing in it. So there's nothing in set A and the empty set in common. So that would be empty. All right. There would be nothing found in the empty set and also in set A as listed. If you did the union, remember you get into a union if you're in one or the other. So all of the elements from set A will be listed as elements from the union of those two sets, even though the empty set will be bringing along no elements to augment that set. So it would just be X, Y, Z, and W. Okay, this is going to get a little bit heavier here. So we got a universal set up there. It's got A, B, C, D, E, F, G, and H. A's got ace, B's got face, and C's got bag. All right, so now we're going to do the intersection of C and B complement. So first of all, it's probably a good idea to list B complement. So if B's got F, A, C, and E, the complement relates back to that universal set and lists everything except F, A, C, and E. So that would be those guys, B, D, G, and H. Now it's probably easier to do what we were asked to do for number 7. Look for the elements that are found in set C and in the set that we've just listed as B complement. And it looks like maybe B would be in there and maybe G would be in there, as they would be elements that were common to set C and the set B complement. Oh my goodness. Again, probably would help us if we did the first part and just did A or C first. So that says everybody who's in either A or C. So that's going to bring along ace and bag. Again, the order in which those are listed doesn't matter. All right, now the challenge is, can we list everything that's found in that set and in set B? So, all right, what do you got for me, Dell? Well, it looks like A is going to be in there. Maybe C is going to be in there and E. Oh, okay, A, C, and E. Got a little extra fast on the click there. Again, this guy's got a lot going on. I'm going to say let's break it apart. Let's do C complement first. So if C's got bag, all right, C complement refers back to that universal set and has everything except B, A, and G. So that'd be C, D, E, F, and H. All right, now we'll do the intersection of A with that C complement set. So that should pick up probably just C and E. And then last but not least, we get to do a union of the set we just listed or B. So it's going to have all of those that we just listed in addition to anybody from set B that was not previously listed. So there would be the set of elements that were either in A and C complement or B. So when you get these heavy ones, tear them apart, go step by step. I didn't go too crazy on this, on the assignment stuffs. I threw a couple, but it's not by any means taking over the world. All right, set difference. Takeaway. When you first learned subtraction, that's what you did. You did it as a takeaway. So what you see here is you start with set B and you take away from it anything that's found in set A. So you can do it just by crossing out. Whatever you have left over at the end is the answer. All right, so I got some examples for us here. First one says, let's start with set B and take away anything that's in set A. Well, set A says you're going to take away an X, a Y, a Z, and a W. So again, grab your trusty pencil. Cross out the guys that you're taking away. You're taking away the X and the Y and the Z and the W. Whatever's left is the answer to B minus A. And in this case, I believe that would be R, S, T, and V. Look at that. Got one right. Okay. Start with B and take away C. So, all right, you got a big old set there for B. You're going to take away anything that's found in set C. So you'll take away the R, you'll take away the S, and you'll take away the T. So again, cross them out. Whatever's left is your answer. So it looks like in this case, it's going to be V, W, X, Y, and Z. Again, any order that you list them. Last but not least, start with A, take away C. Now, that's an entertaining little problem, because if you look at set A, and you're going to take away either an R or an S or a T, which are the elements that are found in set C, I got news for you. There aren't any. So A minus C basically takes nothing away from set A because you had no letters you could cross out. So you wind up saying, hey, this is what I got left from set A. I would have taken away an R and an S and a T. I just didn't have them to take away. All right, we're up to Venn diagram time. So we got some information we're going to process. We got 125 IU freshmen. Some take math, some take biology, some take chemistry. We got overlap sections. It's going to be a hoot and a half. So we got a lot going on with a Venn diagram getting ready to go. So I would advise you grab this information, put it on your desk as we proceed with the next slides. I cheated, I printed it out so I can reference it as we go. So there's my Venn diagram. The circle on top is the math people. We got the biology people and the chemistry people. Now, the thing you gotta be careful is you gotta put these things in. So don't take things too literally. You see where it says 25 people took math? You won't see a 25 anywhere in that math circle. They're going to be broken out into component pieces. So you have to work. So in this sense, we're going to work from the bottom up. All right. So you see where it says 5 people took all 3 subjects. The first entry you're going to get, and again, I'm sorry you can't see the data here. So maybe you got a chance to print that last slide. There's your 5. Those are the 5 people who took all 3 subjects. So now be careful. I know your data says 6 people took math and biology. But again, you're not going to see a 6. You got that little football shape there where math circle intersects with biology circle. And you've already used 5 of those 6 people. So only 1 person is left out of that 6 to take both math and biology. 8 people took biology and chemistry. So again, you got that little football shape where the chemistry circle and the biology circle intersect. So that little football's got a total 8. Again, you've already spent 5 of them. 3 people in that intersection for bio and chem. In a similar fashion, math and chem, 10 people, 5 already accounted for in the intersection of all 3 circles, means 5 left for there. Now, on the last entries, the data says 40 people took chemistry. So if you look at the chemistry circle, you've already accounted for 13 people, 5 and 5 and 3. So if you got 40 altogether, 40 take away 13 leaves 27 people who only studied chemistry. Second data point, 42 people took bio. Already in the bio circle, you've accounted for 9 people. So that means 33 people, 42 take away 9 for bio. The math section 25 already accounted for 11, 5, 5, and 1. 25 take away 11 leaves 14 for math. So now the data stack says 125 were surveyed. You'd have to add up all of those people to find out how many that is. And you probably have some people who weren't in any of those 3 subjects. So that last piece of arithmetic is the sum of all of those blue text box numbers. And then that sum subtracted from 125 leaves 37 people out there in the edge. Okay, again, this is going to be a problem because you don't have it in front of you, but you can refer back. Students who took math but not biology, 19. Those were the numbers that got added, the 14 and the 5. Students who took chem, math, or bio, that's a lot to add together. You just had to be in one of those circles or another. Didn't take any. That one we kind of got. How many took at least math? All right, at least math is 25. Math in tandem with anything else. All right, those are the numbers that got added. Last thing for us is Cartesian product. All right, Cartesian product builds ordered pairs, sets of ordered pairs. So set P has pants, navies, blacks, tans, and grays, and set S has shirts, whites, blues, and pinks. If you do the Cartesian product, sometimes that's read P cross S. All right, so the first set of values for the ordered pair comes from the first set listed. The second set of values from the ordered pair comes from the second set listed. So we would simply list all of the possible pants and shirt combos where pants come first. So you could have navy with white, navy with blue, navy with pink. That pretty much exhausts navy from the pants category. Then you pick your next color, black with white, black with pink, and you list all the possible combinations, and you would have done the Cartesian product. That, my friends, is the end of video 5. This was a long one. So there's your third assignment from Unit 2, assignment 2C from the book. Grab your loose leaf, grab your blank paper, crank out some solutions, and send them to me in the answer box for assignment 2C. Thanks for joining us on video 5. We'll be back shortly with video sequence for Unit 3. See you then.